Okay, welcome to the very final video lesson for the first semester in Unit 2. We are going to take what I did in the last video, which I did a word problem and solved a linear quadratic system graphically. Now we're going to take the linear quadratic system and solve it algebraically. And I'm going to use substitution when I do that. So it's a pretty simple process to make the substitution. It just becomes a little bit tricky when you have to decide how you want to solve the equation. So what I'm going to do, since these are both set up equal to y, I'm just going to take the second equation and sub it in for y on the first equation. So it looks like this. Okay, then I'm going to go ahead and I'm going to shift everything to the left side. I'm going to add 3x and add 8. So this side will just be 0. So now you have to decide. Now you're not going to do it graphically because we just did that, but your other 4 ways, factor, square roots, completing the square, or quadratic formula, you can decide which one you want to do. But I think I'm going to factor this one because 2 numbers multiply to 10 and add to 7. I know kind of what that is already. So I'm going to factor it down. And then I'm going to solve for x. Okay, now on the word problem, we just had to figure out our x's and, that kind of interpret what those meant. For the algebraically, we actually have to figure out the entire ordered pair because that's where they would intersect. So I'm going to plug the -5. I'm just going to go back to the linear function and plug it in there. So it'll be -3 times -5 minus 8. So that y value is 7. So that ordered pair is -5, 7. Do the same thing for the second one. So -3 times -2 minus 8. That's -2, so that ordered pair is -2, -2. So we have 2 real solutions, and we ended up factoring on that. That's what I chose to do. Okay, let's keep moving. This one here, I'm going to do the same exact thing. I'm going to take the -2x plus 9. I'm going to replace it where the y is on the first equation. Oops. Not a cubed. Okay, and I'm just going to shift everything from the left to the right since my quadratic pieces are over there. So cleaning this up, I get 2x squared minus x, and then minus 3. Now this one is also factorable, so I am going to factor, but if you are not a fan of factoring, you can use the quadratic formula right here. So I'm going to do 2x and x, and then if I do 3 and 1, I put a 3 here and a 1 here, I will get 2, let's see, I think I want the plus here and the minus here. So then I'll get for my outer, I get 2x minus 3x, which is -1x. So in solving those, this one will be 3/2, and this one will be -1. Okay, we still got to figure out our y's. So I'm going to plug it back into the second linear function. So negative 2 times 3 halves plus 9. So that y is equal to 6. Do the same thing here. And that y is going to equal 11. So I get the ordered pair 3 halves, 6, and negative 1, 11. And again, I have two real solutions. And again, I did factoring on that one. Okay, let's go down to these two at the bottom. Just make sure you guys can see it. Okay, same process to kick it off. I'm going to put the 72 minus 12x in place of y. Like that. I'm just going to go ahead and I'll just shift everything from the left over to the right. So we get negative 2x squared plus 28x minus 98. Now this one, this looks like a little more complicated, so I'm going to go ahead and use the quadratic formula for this problem. So a is negative 2, b is 28, and c is negative 98. So x equals the opposite of b, plus or minus b squared minus 4ac all over 2 times a. Now when I do this, when I simplify under the radical, I get a 0. So what that means is there's just going to be one real root, one real solution, because plus or minus 0, that just goes away. You know, that's not going to do anything for you. So you end up getting x equal to negative 28 divided by negative 4, which is 7. Sorry about that. Okay, now the only thing we have to do is just figure out the y-coordinate that matches up with the 7. So I'm going to plug it into the second equation. And that is going to equal negative 12. Actually, I'll just make an ordered pair. Actually, I'll put it right there. So negative 12. Okay. So there is one real solution. And I did up here, that is my quadratic formula. Okay, so I've done 2 factoring and 1 quadratic formula. So let's move to this last problem. I'm doing good on time, so I'm going to plug that in for the y. And I'm going to shift everything to the right again. So I get x squared minus 8x plus 25. Now, even if I were to consider factoring here, I can't think of 2 factors of 25 that multiply to 25 and add to negative 8. So I'm going to go ahead and plug it into the formula. So A is 1, B is -8, and C is 25. So opposite of B, plus or minus, B squared minus 4AC all over 2 times A. So let's see. Okay, now under my radical, okay, I would do the 8 squared minus 4 times 1 times 25. You end up getting a negative 36. Okay, now right there, you guys should notice you have a negative under the radical, which is going to generate an imaginary solution. So there is no way you're going to get a real solution on this, and we can't really leave our answers in terms of I when we're talking about the traditional coordinate plane with the xy axes. So this one has no real solution. Okay, because this spoils it. Spoiler. All right, that is it. I'll see you guys later.